Tech Bits. We're here with Ellert van Koperen from Database One. He is a Postgres database expert. And of course, he focuses on Postgres. Welcome, Ellert. How are you doing?
I'm doing fantastic. Thank you very much. Great to be here. Um, let me try to teach you a little bit of Dutch. I'm Ellert van Koperen. That's how you pronounce
Okay.
it. I know it's a challenge. Yeah. So I live in Holland, the Netherlands, in the center of Europe, basically, and that's where I do my things. I work with
Oh, great.
Postgres since the days of when it was still PHP 3. I'm not exactly sure when that was, but it was Postgres 7, I think, when I started using it. That's a long time ago.
Well, we're already at 15 and going on 16, if I remember correctly.
We're
Somewhere
using
around there.
16 and we're already going on 17.
Wow. I keep track and lose track all the time. So,
Yeah,
wow,
and
that's been a while.
the cycle has increased a lot lately. The last 6 years, I think. It's a new major release about every 1.5 year, sometimes a bit more. But we've been stuck on 8 and on 9 very, very long time. And it was a much longer cycle, much smaller improvements per release. The difference between 9.1 and 9.2 was much larger than it was between 14.1 and 14.2, for example. So things
Yeah,
have
there was a
changed, but it's still Postgres and I still love it.
great. That's always a good thing.
Yeah. So what do I do? That's of course what you want to know. I'm a Postgres fanatic. I'm a DBA. And a DBA in the sense that I do database architecture and database administration. That means that I set up databases in such a way that they are resilient. That's more on the hosting side, but also that after a lot of growth has happened in an application, there's not a lot that needs to change. And that's a bit of an art. That's a bit of maybe even a bit of dark magic to forecast. Like, okay, you set it up in this way, you do partitioning in this way, or no partitioning at all. If you make your indexes in such a way, then it is prepared for growth and sometimes massive growth. And sometimes that's necessary. Although usually customers call me after the things are on fire, basically. Yeah.
That's always the case.
Yeah. Another pillar is performance. I focus a lot on performance performance improvement, and that can be both by doing changes to the database, doing changes to SQL statements as they come out of code, very often ORMs, and of course changes on the hosting side, on the server settings. Although very often that has less effect than you would think. You know a lot about that, probably more than me. But yeah, if even if company, if they leave things on default settings, you need to tweak some buttons, but the effects are maybe 20%, maybe 30% if you're really lucky. But a bad query that can have an impact of 1,000-fold.
I've seen
If you,
queries bring down entire servers.
oh yeah, absolutely. If,
Easy.
if somebody is missing an index, in the beginning, you don't notice because that's a sequential scan, but that's because it's a small table, but then it grows and it grows. And then after 5 years, the table is 150 gigabytes and that does not fit in cache anymore. So then it becomes really, really slow. Yeah.
To mention that the select star is always the common denomination for queries whenever they start.
How about select counts?
I see most commonly even select start.
Yeah.
Most of them don't even get to the count. They just do a select start and then look, why is this so slow? Why is everybody starts ganging up and coming to see you? What's going on here? What's happening?
Yeah,
It's so slow.
that's one of the caveats, especially from people that come, for example, from MySQL. They expect count to work in the same way that it does for MySQL. And MySQL, it's maintained somewhere. I don't know exactly how it works, would be interesting. But it maintains some metadata somewhere. So account is really quick. But counting Postgres works different because it is not interested as how it is on this. It has to be ACID. So it has to know how it is on this at the moment that you start that transaction. And then some other transaction might change something while you are doing your count, but your count has to be correct. So if you want to know an exact number, you get an exact number, but it has to scan everything. So it already gets interesting. Just a stupid count.
Yeah, definitely. There's so many things in Postgres and that are not always taken into account. And that's why it's great to have someone like yourself to join them, start analyzing their systems,
Yeah.
their database management system, because there's so
And
many
then,
pain points.
and then comes the third pillar of what I do and what I actually like and love to do. And that is I teach. These wisdoms, I teach them. I give a course, PostgreSQL for coders. So computer programmers that are usually in a company setting, and they get drafted as a volunteer to do the database next to their usual work. And they have all kinds of excuses not to do those things, especially not to look too deep into why queries are performing not as well as they could, because of, well, you can think of lots of reasons, and they all don't apply really. If you wait until it is on fire, you can do coding now and do the nasty things when they are really necessary. And then you end up in a situation that things are actually on fire and the database does not respond in time anymore and your whole system is down. You can then still call me, of course, sure. But that is a bit too late, isn't it? And another great one is, well, can't we just call a DBA to do those things when they are necessary? Yeah, sure. However, sometimes these things are things that need to be done in the application because you're doing things improperly. And these are not things that you can actually change in the database and expect them to work. I, I have a nice example from practice where they stored usernames and encrypted passwords in a table. And every click on the web page, these things were checked. Yeah, I'm not exactly sure why, but this username was checked. Like, do you still have access to this area of the website application? But in the application, the usernames were made uppercase for some reason. But in the database, they were stored case as you type them, basically. They had some conflicts with usernames. Some people that are named the same, they have short names and then they can overlap. I don't know. So if you feed an uppercase name to a query, that doesn't match. So you need to do a function. So you need to check it uppercase. If you uppercase a value in a table and then compare it, indexes don't work anymore because they are, of course, scan sensitive. So that's the table scan for every click on that website. Full table scan. That would be an easy fix, but you need to find these things and you need to realize this is really a problem. Now, of course, there's PG stat statements, wonderful extension. Everybody has to have installed everywhere. I mean, it generates 1 or 2% extra load on your production server, but it can save your neck. So you should, everybody should always have it installed. It should be in the core. It should be always available by default. But even if people or companies have it installed, have it running, nobody looks at it. Things are on fire.
Very rarely.
Yeah, I don't know. And yeah, there are some issues with PG stat statements. Every query, it is like, let's say, pre-compiled, tokenized, and then stored. And the query plan that goes with it is also stored. Each of these queries gets a query ID. Very simple. Except that if there is an in clause in a query, every number of parameters in the in clause generates its own query ID with its own query plan. And PG statements recognizes it as a different query as the other one with different number of parameters. If you have 2 in clauses or 3, you get the Cartesian product of possibility. So that can generate
not
1,000 query plans or 1,000,000 query plans. And they're all different. And they all end up somewhere down at the bottom of your flow queries. They don't flow to the top because they are all different. So you need to somehow bunch them up together. Now, of course, I generate query to do that, but not many people know this. So yeah, there you go. There's
That's what they
already
call
an
the
issue.
expert like you. Yeah, because
Yeah.
that's the whole idea.
Yeah.
When you
Yes,
first
and
carry
no.
bar, that's what it does. Yeah.
It would be nice if this is eventually addressed in PG statements itself. If they could just have a version of the view that bundled queries together that seem to be really similar. Another caveat is, for example, if you do explicit naming of tables. If you name a table A and you have a similar query that names the same table B, and the rest of the query is the same, they will be seen as different queries.
Yeah, that's
There
bugs.
are ORMs that do this.
ORMs are another headache there.
Yeah. There's a good target for jokes. Yeah. Yeah. So yeah. Oh, there's so much there. I started making a compilation of. I started naming it standards, guidelines, and rules of thumb, and then I encountered this fantastic movie of Mel Brooks, History of the World Part 1, where Moses comes off the mountain. He had just spoke to God, and he has these 3 tablets, and he writes one. And he says, "Here are the 10 commandments." And so these are
That's good.
yeah, it's a fantastic movie. It's one of the movies that I show to my kids. I mean, these days movies are not really part of education of kids anymore. But my kids have to watch a couple of movies. This is one of them. History of the World. They have to see The Life of Brian by Monty Python. They have to see Terminator and Ghostbusters. That's basically what I grew up with, and they have to see it.
Classics.
Exactly. So I have these 10 guidelines that I compiled. They are on my website. You can just click on my blog, go to the guidelines, and download the PDF. And they are about naming things. What can you say about naming things? A lot. It's really, there's really a lot of subject matter there. It's really
very
important.
comprehensive. We might have to set up a separate podcast just for that, to go through the PDF,
Absolutely. Yeah. There was somebody that said, like, there are 3 things. No, what did he say? There are 2 things that are really, really important in computer science. That is naming things, concurrency, and off by 1 errors.
Very true. Those are very true.
Oh yeah.
Very, very true.
Data types to avoid. There is a lot of legacy stuff, especially in Postgres, and that is mainly to comply to the old SQL standard. And there are there are data types in there that have like caveats. How you call it in Dutch? You say haken en oog, like hooks and eyes, and they all just make a sticky mess. And the usage of the appropriate data types. That's the opposite. Some data types you should avoid. Some things you should just not do. I can give a very short example. Don't use the database as a key value story unless you specifically add that. You can use HStore extension, and then it's specifically meant for that. But I have seen people doing, well, silly things.
Well, probably that might come from the Postgres is the all-in-one database. Maybe they took it too literally.
It's eating the world, but not set up as default. And I mean, Postgres is not Mongo. It can function as a Mongo database, can do it very well, but you need to do some things before you can start doing that. For example,
Yes, you have to set it up. You have to time it.
install HStore extension and set up your whole data model in a way that makes use of this. There's a great example, maybe not so great example, of an application that does this by default and does it really, really badly, and that's WordPress. Most people use WordPress with MySQL, which is horrible. You can just as easily use it with Postgres, but it does exactly the same and it does it wrong. So if you wonder why are WordPress websites slow, it's because they use a normal relational database as key value store. That's one of the core problems of WordPress. Anyway, let's continue with the little shorts.
Look, there's so many things. No,
Oh yeah.
this is great information you're mentioning because many overlook that. These
Oh, yeah.
small little things, they're rarely even thought of.
We're not done with data types. The third chapter is beware of limits of some data types. I'll give some examples later. I think that's
Sure.
Next one is column order matters. Did you know that?
It should matter. Yes, definitely. But it should. It does most of the time.
So the silly thing is that in Postgres, and that's something that comes from the heydays when they started making the database. Postgres is built in C, and memory management in C is really, really complicated. And to make it a little bit more easy for themselves, they work with alignments, byte alignments in memory. And they align a data type on a number of bytes equal to the size of that data type, except for variable length things. They are aligned on, I believe, a 4-byte boundary. So if you have a Boolean, which is actually an 8-bit int, and after that you have a double, which is an 8-byte data type, numeric. In between, there's padding to make sure that the double starts on a whole number, a whole multiple of 8 bytes in memory. And then in between, there's a gap, 7 bytes. It's just wasted. You can fill it, but you have to do that explicitly. So they call this, hold on, column Tetris. You have to do column Tetris, and you do that by bundling all the short data types, then the slightly longer data types, then the longest data types, and then the variable length data types. And nullable things are a thing on its own, because Postgres is really smart in that. It has a bitmap at the beginning. And if something is null, it has a bit there. It said, this is null, and it's just deleted from the order. But that is also why it's good to have all these things bundled together. First the long ones, then the short ones, or the other way around, so that they fall away and they get compacted. If you do it first one, then the other, then it some gaps fall in and you get lots of waste. I see lots, couple of bytes. Who cares? A couple of bytes. Well, multiply that by, I don't know, 100 million records, and
Adds up very quickly.
it adds up. I mean, the header of a row with no data, that's possible. Eh? You can have a row with no columns. Not sure. It's 26 bytes. And the rest is information that you actually use. If you have a bit of a compact data model, you can have, for example, 300 rows in a data page, maybe even 400 rows. A data page is 8 kilobytes, and that is what Postgres uses for everything. It stores all this in blocks of 8 kilobytes. It has it in cache in blocks of 8 kilobytes. Everything works in these blocks of 8 kilobytes. So if you have like 10% of wasted space in your data, that means that you have 10% less rows in a data page. So the chance that when you do a read, that it is already in cache is 10% less. So your queries become not 10% slower because your disk is much, much slower than your cache. So your queries become much less than much, much more slow than 10% of difference of this padding. So it's not only wasted space, it's also wasted effort.
Yeah, because it exponentially adds up. Not just adds up, it exponentially just completely blows up.
Exactly. Yep.
You know, that's tremendously insightful.
Yeah.
And I'm
So
glad you
column
mentioned that
Tetris.
because
There's another way to do this. That's so cool. You might be familiar with timescale.
it rings a bell.
So what they do is in their hypertables, they bundle multiple versions of the same data over time. So you have, for example, measurements of temperature. Then they take a whole chunk of these temperatures and they do a kind of encoding to compress it into one row. And that
They
saves
downsample it.
well, but losses. And it depends on the data type, how they do it. They can use zip compression, basically. That's especially for text and things like that. They can also do like a delta encoding. That's more for integers. And then they do a delta encoding. They do it again as delta encoding. And then they do a run length encoding. Sounds very fancy. You can just look at how it works. It's really nifty. They can save about 85 to 90% of the space. And that has consequences for your cache's hit results. There's also a downside. Exactly. It can work faster. There's also a downside. And that is that this compression is labor intensive. And you can do a change on something that has already been compressed. But that means uncompressing it, making a change, recompressing it, and hoping that it fits. Because if it doesn't, you get a page split. And then it's much, much slower. So it's not black and white. It's not end all be all, but it's nifty. And it prevents you. You don't have to do column Tetris anymore.
Well, the other side of it too is the compression alone. Being able to put it between 90%, 85%, or 95%, that's going to be really
It can be
have a
huge.
tremendous impact.
It can be huge, but for things that are like a lot in flux, it really doesn't work. It has to be things that are stored and then looked at until they're not necessary anymore, and then your partition falls off the table, basically. For that, it works really, really well. For things that are more continuously changing in flux, things that have to be updated all the time, it doesn't work so well. That's also why they you can set when the compression starts. You can also do it explicitly. So you can say, for example, you store it in chunks of a week. And if a chunk is more than a week old, 2 weeks old, you start compressing it. And then it happens automatically and all transparent. Yeah, it's great.
Yeah, that definitely sounds very useful. And
It is. It also, it has several downsides. What it told you, if it's in flux, it doesn't really apply. But it also adds a layer of magic, let's say. There are things happening that you don't really understand how it works. Sometimes data is less well compressible suddenly than you expect. For example, there's jitter on the line. There's just little variation, something. Yeah, then things are not so well compressible anymore. You suddenly get a lot of changes because of whatever reasons. That has to be done. It all has to be compressed. Lots of problems. You have an existing table. You have to do like, you get a lot of data and you have to backfill it on a compressed table. Yeah. Things
well,
are
I'm sure
always
they'll
more
come up with
complicated
some
than you hope for.
fixes.
Oh yeah.
Well, databases. That's the nature of databases. You have some functionality, then you add more functionality, then you have to make it all work together. And that's where we come in, try to help them alleviate those pain points. Sometimes it's really hard to alleviate them. I've been in cases in which no disaster recovery procedures. There's nothing you can do, and people are just losing it, pointing fingers at each other, almost about to the point of biting each other's heads off.
If you're
So,
at that, if you're at that stage, then it's time to look for a new job, I think. But yeah.
yeah, it's a good thing whenever you're coming out from as an outside resource, and you don't get your head chopped off. Those who are in there, it's not pretty. Some people
No,
just kind
no,
of
no.
walk
It's
away.
if you get in a situation like that, it's a hope that you can do things remotely because the atmosphere. No, 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 no. Not pleasant.
What have been? Have you run any interesting scenarios of that sort that are unique, putting it that way, in your experience there with in the entire industry? I'm sure we all have those type of scenarios, and funny stories
Um,
for us, maybe, but maybe not so much for others.
I have run into dumpster fires. Absolutely. There are some things that I'm not allowed to talk about, but yeah. Um, the most funny thing that I have seen was actually not Postgres. It was a MySQL database. It was a database that did not have. Okay, I need to explain this. In um, in Postgres, an index is just an added thing on top of table. There is no such thing as a primary key in Postgres. In Postgres, you have a primary key, and that's basically a macro. It means put an index on there, make it unique and not null. And because it's such a special word, you are allowed to have only one of these. You can have multiple indexes that are an index and unique and not null, but only one can be named the primary key for reasons of backwards compatibility with the SQL standard. But that's not how we implement in Postgres. In MySQL, that's very, very different. Like it is actually, I believe, also in SQL Server, Microsoft SQL. In MySQL, and I believe also in SQL Server, a primary key means the index determines how the data is organized on this in the table itself. And the primary key is inside the table itself. It's not on top of the database, on top of the table. If there is no primary key defined, now it becomes interesting. MySQL assigns one. And the contents of the index is all the data in the row. Everything.
Wow.
The entire row. So if you have to change something in a table like that, for example, if you want to add a column, it has to change the primary key. All of it. And if that is a table of a terabyte, it
That's gonna be
takes
messy.
2 months. It actually happened. It took 2 months, 2.5 to be precise. 12 months to change, add column. Adding an actual key help. Yeah.
Yeah, that definitely. You don't want to be doing 2 months for a change.
No,
Like,
no, that's just silly. The alternative would have been a dump and restore. Was the system that had to keep on running and reasons.
oh,
Shall we run down the 10 commandments, the rules, guidelines?
keep on going with the commandments. Yeah.
Yeah. Where were we? Column order matters. Okay. Find bottlenecks and worries. Oh, this is great. So a lot of companies, they host things and they monitor the server, but not the database. If the server runs out of memory, there's a problem. If the server runs out of disk, there's a problem. But if 90% of the transaction fails, nobody knows. So
Okay.
there are things that you should not ignore. Don't ignore slow queries. Use and check, not just install, actually check previous stat statements and log slow queries. It's there, so use it. Use and explain to get an indication of the amount of work that the database will do when you create something. You can use an ORM, that's fine. It generates SQL, and you can, in all ORMs, somehow Some it's easy, some it's a bit more convoluted, but you can always get the generated SQL and use an explain and try to read the plan, the query plan. And reading a query plan is not always easy. You have tools that make it a bit more manageable for you, for anyone. But learning to read a query plan is really, really important. Let's say a coding life skill.
Yeah,
Reading a
you need
query
to
plan
know.
is really, really important. Yeah. And so in Postgres, you get these effort metrics that come out of a query plan. And they are basically what, do you remember in the 90s when you install Linux, it made an estimation of how fast the processor was. And it called it, this processor has 3,500 BOGO bits. That's like a nonsensical unit. Basically the same. It's just an amount of effort that is like an average of, not sure what, processor, memory, disk, cache, whatever. They say it takes about 800 effort, 800 units, bits. That's fine. You can compare these things exactly. So if one query is 800 bits and another query is 400 bits, then that second query is twice as fast. Usually, you have to use it with actual data and then you know the real value. But you should check these things. And sometimes a query can be shockingly slow.
And you know, that's one of those things that you always see. Let's implement this query, put it there to work. You never test it.
Does the query give the result I want? Yes. Okay.
Does it do it optimally?
Click.
Who knows?
Let's go.
So-
In production. It works.
As simple as that. You test,
Yes.
you know.
Mhm.
You test your code, test your SQL. That's pretty much the
Exactly.
idea behind it.
And the last one, and that is the best one. Don't ignore slow queries. Ignore warnings, and you especially don't ignore errors. You have to use and read the damn logs.
That's
And
often overlooked.
and this is so important, especially cloud and Kubernetes hosting, because there's even more of a vague concept like, yeah, it's there somewhere. There's probably also logs. I don't know. They're there. And if they're not there, they should be switched on. And you really have to have these things logged and you have to analyze and read the log. So important for the longevity of your application and to prevent like the sysadmin calling you on Saturday morning that everything is down.
Yeah, they're the first one. It's always the database, the one with the problem, not the application. It's the database, the one.
Well, that's eventually the thing that falls over because funny business happens. And yeah, I mean, if the application server itself, I don't know, tech faults, crashes, core dumps, that's easy. If the database is just slow and then becomes really slow, and then the application times out, and then you blame the database. Obviously. Normalization. So I have studied computer science in the 90s, early 90s, and normalization was a hot topic. It was so important, normalization. So there's basically a Goldilocks zone of normalization. And the extreme normalization, like 4NF, 5NF, kicks, and all these letter combinations, normalization points, they're really over the top. On the other hand, unnormalized data and people storing arrays and character values and not good either. That's one of these areas where you can have a rule of thumb, and that's about the best effort you can have. You have to have a gut feeling like, yeah, this is normalized enough. This is probably going to perform well. You can over normalize, but you can actually also not normalize enough. And both are harmful. So yeah, that's the thing.
Yeah, because there's up to 8. I remember, if memory serves correctly, 8 normal forms.
I think there are like 5, and then some exotic things that people invented, and they gave them different names, but they don't like they don't stack on top of each other. Whereas the first 5 do, or at least the 4.5 or something. It's
Yeah, because I remember studying up to the eighth, but pretty much once you get past the fifth, it's almost a table with a key per column, which that's
yeah,
pretty much, imagine just trying to do a join on multiple tables
yeah. No,
on multiple columns.
that you
Insane.
get in the area of the Spark, Apache Spark or Mongo, basically. That's
Yeah, it's completely.
that's
Then third is usually the rule of thumb, safe enough to think
yeah,
about.
exactly. First, third, or fourth. Um, but these are rules of thumb, and you can always deviate, but not out of laziness. You need to know why you're doing it. It's so important. Um, oh yeah, then this is a great one. Business logic.
Oh,
Where does that live? You can have lots of fun things in your database. You can have triggers and functions that do things, and you can have CTEs that do all kinds of stuff for you. Um, you can make them quicker by materializing your views. Yeah, that's all possible. You can even have recursion in functions. Oh, great. You should really never do that.
never do that.
No, absolutely no. So it's really important to know where your business logic is. You can choose to have business logic in your database as long as it is generated from one source. There has to be one truth. The business logic is, for example, in a code repository. And then some of the business logic goes into your application in whatever language you have as an application layer. And some business logic goes directly into the database, but it has to be present in one sort of truth, preferably in one group of files or even in one file for every block of functionality. For example, checking your variables and naming something. But what is really, really bad, and I have seen this and I have been guilty of actually advocating for it, is second guessing another team. So you have business logic in an application, and the database team says, you know what? We should recheck all these parameters. That's fantastic. Until something changes. And then it changes in the application, it doesn't change in the database, and nobody understands why it doesn't work anymore.
There has to be communication between both. Standards.
No. That's not enough. Because there is communication, and then one of the team leaves, and another comes in and doesn't communicate so well, and then the other team, somebody leaves, and everybody forgets that there was communication. But you still have to maintain the application. You have to have one source of truth. There has to be one place in your code repository where the business logic lives. That is how things work. And where it is then implemented is irrelevant, but it has to be one source of truth. It's so important. The easiest way is to have all your business logic in one spot. Either all in the application or all in the database. Obvious. But that's hardly ever possible. It is possible though.
Yeah, but at least you have a good idea of how to implement it, and you're mentioning it because I seldom hear anybody even talking about business logic anymore. I remember 10 years ago, it was business logic, still business logic everywhere. Then suddenly it started dumbing down, quieting, and then
Yeah.
you never hear about it anymore.
No, and that's mainly, I think, mainly due to ORMs, because ORMs take a lot of things out of your hands. They make it really easy. They make it also really easy to forget it. That's true. But then there's always a situation where you think, it would be really handy if this and this, and then you start to talk to the DBA, if you have a DBA, or the programmer that is handy with databases.
The volunteer DBA.
I can do this with a trigger. Great, do it with a trigger. And then they build some triggers, and they build some more triggers, and let them views and some CTEs, and then nobody understands the application anymore. That's how you how you generate disasters. Yeah.
Yeah.
So business logic. And the last ones are really, yeah, everybody understands this, I hope. Maintenance. You have to do maintenance. Sometimes you have to do a full vacuum. And yes, that means that the table is locked and you have downtime. It's true. Sometimes you have to do it. Sometimes you have to upgrade your database. And the best way to upgrade your database is actually create a new database, do a dump, restore on the new database, and throw the old one away. Because then it's a full vacuum and it's a new machine with the newest operating system and the newest version of WordPress.
You know, that's a great
Maintenance.
thought. Most of them just keep it going. And then you keep all this accumulating all this overhead.
I
Garbage.
have seen a Postgres database that had an uptime of 800 something days. They were really proud. I can imagine.
Of course.
Of course, it's great. But yeah, in IT terms, that's antique. And don't touch it so it doesn't break, you know? If it ain't broke, don't touch it. You don't always know it's broken. And if you're still running on Postgres, I don't know, well, it's time. No, it's not time for an upgrade. You had to have done an upgrade 5 years ago.
And you know what? You'd be surprised how many organizations we depend on that actually operate in that manner. They don't touch
Yeah.
it. It works. It doesn't. That's it. Leave it be until it breaks. Then we'll talk about it. Keep it going until it dies.
It's understandable. It's the really conservative way to do things. But the problem is that if you don't upgrade in small steps, you have to do your upgrades in large steps. And with large steps come lots of changes and lots of problems. And this method of continuously checking updates, trying to upgrade as soon as it is feasible. For example, now we are on Postgres 16.2, I believe. So upgrading to Postgres at least 15, the time is now. You should be on Postgres 15 so that when Postgres 17 comes out, we can upgrade to Postgres 16. That's stable. But sometimes, on rare occasions, this can bite you in the backside. The famous case is, of course, Postgres 14.3, where there was index corruption with create or reindex concurrent. I don't know if you followed the news. That was a while ago already, but there was a hidden index corruption if there were transactions on the table while a reindex was taking place. And index corruption, it was an invisible form of index corruption where you would just, if that index was used, you would miss some value. And that's really, really bad for a database. You just give a wrong answer.
Yeah. When you start losing your data and not having enough representation.
The index didn't know about it.
And that's the impression, because many would think, oh, we lost data. That's the first impression. If you don't see it, the immediate impression is we lost it.
Yeah.
But then you start digging and seeing, oh, it's there. But then I can already imagine any banking institution or any highly number dependent or financial transactions, they must have freaked out immediately when they started seeing them.
And the fix was super easy. Just don't, in that version, don't use create or reindex concurrently. Use the traditional way. The reason for having concurrent index creation and reindexing is, of course, that you can do it while the table is being accessed and while you are actually writing to the table, whereas non-concurrent index creation locks the table, which can be really bad. I understand that. But yeah, in this case, that was a bit of a whoop. And to be fair, at least in the last decade, that was the only really, really big issue that I have seen. For the rest,
You got to give it.
nothing.
Yeah, the community does a great job with that. I know that there's a lot of people dedicated to that. They've done really outstanding.
Absolutely.
All these tasks and people involved always are going there, just like
Yep.
yourself, exposing and educating others. And in many user groups all over the world, all these PG conferences are great. And not
Absolutely.
a lot of times I missed.
That's the good thing. If you have the time, if you have the possibility, go to Practical.
It's
There
a
are
well
several
worth
in the
investment.
US. There's one I believe one in Canada. There's the EU one for whole of Europe. There's one in Asia. It's fantastic. You will meet, you will meet so many database nerds all over the world, all, from all flows of life and in all kinds of professions that you wouldn't even imagine that they would give progress. And it's such a nice community. You meet new people that you wouldn't have dreamt of meeting and having a dinner with and toasting to Postgres. Yeah. Being there, seeing
Yeah,
it, yeah, it's really great. Go to at least one Postgres conference. If you are somehow involved with Postgres, you need to be there.
it's a must, part of the educational process.
I think so too. Absolutely. Actually, that's where I met you.
Yeah, we had a great time at PGCon Berlin in 2022. It
Exactly.
was amazing.
Was it 22?
It was amazing.
23. Yeah,
22.
22. You're right. 22.
22.
Yeah. Prague was 22. Time flies.
Yeah, Prague. I wasn't able to make that one though, unfortunately, but Berlin was awesome. It was just amazing people. Met you. We all got to present and attend all these great topics and conferences and presentations.
Yeah, I did a lightning talk there. That was funny.
Oh, I wasn't able to attend. I was presenting. I think I was concurrently presenting at that time. That's why I probably missed it.
The lightning talks were at the very
The end?
end, and some people had to leave for the airports already. Yeah.
Oh yeah, that there because that's the last call.
What I presented there was a terrible hack, which I will say after the last topic.
Okay.
The last topic is indexes.
Oh,
Having a correct
that's a good topic.
index can make or break the performance of any database. If you have an index, but actually the index doesn't index what you're looking for, the index is not used. The Postgres query planner is really, really smart. I mean, somebody said, like, if you flunk out of query planner education, the query planner school, you're not good enough for that. You can always become a rocket scientist. Don't worry.
There's always a backup there.
Yeah. It's really, really nifty how that works. Because in like 20, 30, maybe 100 milliseconds, it parses so many options, so many combinations, because the fan out possibilities so extreme. It is not just exponential, wildly exponential. Every join gives, I think, like a 50-fold more combinations to look at per table, because of all the ways that you can join. You can change the join order. In some cases, that really doesn't matter, but it does matter for performance because you want to filter as soon as possible. You can use different kinds of indexes. You can use the different indexes that you have. You can use these indexes in different ways. You can filter in different ways. There are so many possibilities there. And still, Postgres manages to just make a snap decision. I use that method and it does it. And it's usually right. Not many databases can say that, but Postgres, it's usually correct. If it says, in this case, I think the query plan is better if you do supercharge on this table and then join it with that, and it's usually correct. Not always. There are some cases where the index chosen is not the right one, or where the query plan chosen is not the optimal one. And that is usually due to the statistics, because Postgres has internal statistics on every table, on every index. And one of the things that it has to do is like make a stochastic analysis of the values of a column that is an index is working on. And also on a column that is not working on if you're doing a search on that column. And this stochastic analysis determines for a great part how an index is and how an index is used. So if your index is not used, where you expect it to be used, it's usually a problem of not doing a vacuum analyze. And these things are done automatically, but the default settings are not great. Usually, a new analysis is run after 20% of your data has changed. In a regular database, 20%. Okay. If you store transactions and after 5 years, your data has piled up to, I don't know, 100 gigabytes of transactions, so 20 million records, I have no idea. Then 20% means an entire year of data. So this analysis can lag behind an entire year. That's not good. That's really not good. So there are some defaults that you really need to tune. And there are some very knowledgeable people that can do that, of course.
Sure. Of course. You're so counted.
Absolutely. But there is more. You need to have correct indexes, but especially important is the understanding of how multi-column indexes. There are some people that work with databases that were still using phone books. They exist. I have been using phone books until I went to study. I'm that old. I'm almost the same age as you.
Sitting here. So phone books are still a thing. My kids tell me, what's that? They never dealt with that.
Kid of a friend of mine said, "What is that thing? Did you 3D print the save icon?" That was floppy disk.
Oh yeah, that's a good, because they still use it for certain applications there.
So in a phone book, things are organized by city, then by last name, then by initials. And if you are looking for Mr. Ortiz, but you don't know in which city he lives, you have a lot of data to go through. Yeah. If you do know the city and you do know the first name, but you don't know the initials, you have narrowed down the data that you have to look through a lot. Now, this is exactly how multi-column indexes work. They organize things in an order. And in a phone book case, it's first city, then last name, then initials. And in the multi-column indexes, it's the order that you define them in the multi-column indexes. That can be exactly that. And then the exact same problem arises. So if you are looking for, you know, the initials, but you don't know the last name and you do know the city, you still have to go to the entire city. That might not be ideal. And if Postgres says, okay, this is above a certain threshold, then it is not efficient to use the index at all. We'll do a sequential scan. Oh, joy. These are important concepts to understand. And if you understand them, you can create an extra index with the correct column order. The last one, that's it. You can ignore if you want. It uses the columns in order that they are present, but it doesn't have to use the last ones. If you want to know everybody, the phone number of everybody that lives in I don't know, Amsterdam, it can go through the city of Amsterdam. It does not have to go through the city of Utrecht or Washington. It can only concentrate on Amsterdam. So then still in that case, a multi-column index will work.
That makes complete sense. Complete sense. Complete.
I had something for after this, but I forgot.
Look, you mentioned about your lightning talk that you had talked in 2020.
Right. The lightning talk. Thank you. You have better memory than me. Yeah, the lightning talk. So I discovered a couple of years ago, I discovered a very nifty trick, and that is a way to combine a date and an ID in one field. Why the hell would you do that? Well, if you partition data, you usually partition it on a date. That is the most used, or sometimes on things like company ID or city, but that's a bit far-fetched. So if you have, for example, orders, you organize the orders per month and you partition it per month. But with the orders from order lines, they should also be partitioned per month. But do you know the date in the orders and in the order lines? I mean, do you put the date in the order lines in order to partition them? No, usually not. You put the order ID in the order lines. You can't really partition it. And if you do partition it, there is friction there, lots of friction. So what you can do is in the order ID, include a date. And if you put the date all the way at the beginning of for example, a big int has 19 decimal characters of data. It's huge, the numbers that you can put in there. So the first 6 digits of a big int, the most significant 6 digits, you can put a date in there, a human readable date. So for example, 24/04/20. That's the date of today. And then a list of zeros and then maybe a 1. That's the first item. You can partition on that. And then by just knowing the ID of your order line, you know the ID of your order, and therefore you know the order ID that the order line is linked to, but you also know the date. And reverse, if you have an order line with an order ID in it, you don't only have an order ID, you also have the date because it's in the beginning of the order ID. So you know in which partition you have to look. The database knows in which partition it has to.
Makes it a lot more efficient.
Makes it a lot more efficient if you have partitioned on the date or a month or something date related. Now, it doesn't work as fluently as I make it sound, because I have implemented this for a customer. We started about 2 years ago, and they're now running into some problems because in some joins, the database does not understand that this item of information contains actually 2 things. It's an ID and it's a date, and the date, it relates to the partition. It's not be all and all.
It's one column. Just look at it one value
with 2 bits of information in it. The sequence and the date. And you mesh it together and you have one value. And you can partition by range. And the range is just the first 6 decimal digits. If you use a human readable date, I propose to do that because it's just really cool. If you can just save from an ID, that's what's that day, that month, that year. It's just so usable. So I presented this idea in the pitch calls, and then I came up with what if, but I quickly said, if you have a sensitive stomach, this is maybe the moment to look away because this is really hacky. Was so cool. Yeah, now, these are things that sometimes pop up, and sometimes they're really usable. They can make things so much faster. The cool thing is that if you apply brain power, you can make things sometimes factors quicker, magnitude. If you have not really a great join, for example, you can make a query 10 times faster. If you're missing an index, you can make things 1,000 times faster. Really, multiple magnitudes. Now, things that come out of ORMs very often are not right. I mean, the SQL that is basically the most common denominator of SQL knowledge. And the ORM knows nothing of the data that you store in your database. For an ORM, also a database is just a black box. Bucket, throw data in, retrieve it with some standard meshed together SQL. That's why it's important to test your SQL. But it's actually harmful. The SQL that comes out of ORMs can be so bad. I made a estimation. It's a bit of guesswork. But in the companies that I have seen ORMs generate SQL, I have made reports that 80% of the effort that is spent by the database doing SQL work is wasted effort because of bad SQL generated by ORMs. Let that sink in. 80%. So
And
you could scale down your database by like memory, CPU, IO by 80% if it would be good SQL or if it would be SQL made by humans. So if you multiply that, and this was only Postgres databases, if you multiply that by how many databases there are in the world, it's a bit hard because it's not licensed. The licensed database with SQL Server and Oracle, well, not everybody, but some people know exactly how many Oracle databases there are in the world. Nobody knows exactly how many Postgres databases are in the world, but we can guess. And we can guess in a really strange way because there was a survey of how many, what was the percentage of databases that have their ports open to the wide internet. You can just do knock on the port like a fork. You knock on the port 5, 4, 3, 2, 1. You get prompt like, oh, what's your password? Yeah, there was a shocking amount. And if you multiply that with like, let's say that about at most 10% of DBAs configure their stuff so bad that they export their ports into the internet, you come down to about 7.5 million Postgres databases.
wow,
7.5 million. Yeah. And if you then multiply that by the average size of a cloud server that runs the database and how much energy it uses when it's not in use versus how much energy when it is in use, you come to a shocking conclusion. That bad queries from ORMs on Postgres waste 900 megawatts continuously.
well, I've been always, I started playing with ORMs a while
That's
ago.
just energy. And of course, cooling of the data center. That's just energy. That's not the hardware, just the energy waste. You can scale down all these databases. That's a lot of less hardware waste, but just the energy. Now, in Germany, there's a power plant. It's coal power plant. And that is, I believe, the biggest coal power plant in Europe, Hagen power plant. At peak power, it generates 875 megawatts. That whole bloody power plant could be switched off if everybody would write good queries. The whole power plant can go. That's
Well,
1.5 coal barges per day, by the way.
ORMs were pushed really hard for some time and they're still being used, but I've also seen many of them back off. I've even seen, I think we had a talk at that PGConf EU 22 about not using ORMs at all, just sticking to, as you mentioned, human SQL or good enough SQL.
Good enough.
Somebody who,
Well, there is actually, there is also a Goldilocks zone there. I mean, if you write an application doing all the SQL by hand, it's actually a lot of work. And what I have even seen is that people then resort to, I'll make a kind of SQL generator myself because I'm not allowed to use an ORM. And then you're in the same shit. Really. You're up. Let's not use vulgar expletives there, but up shit creek without a paddle.
yeah,
So no, that's not the way. But in many applications, there is like this 80-20 rule or 90-10 rule that like 10% of the statements generate 90% of the database load. So these 10%, they need attention. The rest can be ORM. That's fine. And you can always use stat statements as long as you bundle all the bad queries together. You can always use feature stat statements to find out the culprit.
yeah. On the other hand, the other side, you have all the costs for maintaining and compensating for all that SQL query created by the ORM. The cost you have to vertically scale, or sometimes even horizontally, just to keep up with that. And that's one thing I've seen that many have resorted just to say, you know what, we'll eat the cost of having to make all the SQL, just drop the ORM. And many of them have been like no RM. They've been, once they've done that, I've seen that most of them just say they banned them.
It's
So
not
that's
worth
what you don't.
it.
Yeah.
It's just not
Once I
worth
see
it.
the different, because one of them, I think they were talking that they would have to have a small application for something like 32 CPUs and 128. They removed it, and it was something drastic, like 8 CPUs. That's a four.
Yeah.
And they were just eating up the cost. It dropped it completely.
It's always a difficult thing to analyze properly in advance. I mean, okay, one server with 32 CPUs, is that worth it? Not sure. On the other hand, if it is an application that should be online all the time, you're not there with one server. You need to replicate your database. You need 3.
Mhm.
And you need extension, you need test platform, you need a development platform. So maybe you need, I don't know. Well, there's a difference. There's a difference.
Yeah, because if you use 32 all across and it works on 8, that's going to cost you a lot less.
Exactly. Yeah. Now, of course, in your development platform, you probably will not use a 32 CPU machine to run your database in Triplo with replication and everything. But in
It's
acceptance,
usually,
it's good because it should be exactly the same as production, preferably with production data.
and some organizations want to keep it standard, just to have identical all across dev, stage, prod, QA, everything. They
Yeah,
keep it
yeah.
just on across, just to not have that. Oh, it works on this one. That
You call
usually
it staging, right? I understand this, but it's really costly.
yeah, that's where it adds up a lot
Exactly.
quickly. Wow, we just flew by an hour.
Oh, it's already.
Easy.
Oh, I wanted to talk about data types to avoid. Oh, that's so funny.
Okay.
Timestamps without a time zone, for example. Somebody described it as a picture of a calendar or a picture of the clock. Because you don't know what it is, what it means.
Yeah, it's still hard to understand.
And sure, I mean, juggling things with time zones and without time zones and casting them to the correct time zone, etc. It's tough. But this library that's behind it, that works with time zones and with time and dates, adding and subtracting and with periods and cyclicity, they're so well built. You should use them. They're there. Don't reinvent the wheel. Just don't use anything else than timestamps with time zone. You should use it.
Great advice.
Char N, like 6 characters. And you know that if you put a string of 1 character in a character 10 string, it will insert 10 characters. You're 1 character and then 9 spaces. That's just silly. Don't use it. Just use text. For her N. For her N, it's just text, except that it is chopped off at where you put your N. It is not in any way different than just text. It's a text value. My favorite, UUIDs. Some people love UUIDs. I hate them. I really, no good word for any UUID except UUID version 7, which is now starting to get some traction. In UUID 7, there is actually a date or timestamp at the beginning, at the most significant bit of the UUID. Like I proposed with BigInt, now they're starting to do it with UUID. And that makes it that the distribution of UUIDs is much less random, which is a good thing if you use them for anything that is somehow related to the age of your data. If you rely on UUIDs as your main key, every insert that you do is somewhere. An insert that you do today could be next to the insert of yesterday, or it could be next to the insert of 6 years ago. Distribution is stupid. But there's one worse thing to do with UUIDs than just that. And that is storing a UUID in a text value. I have seen this. Please don't do that. The money data type. Just ignore that. Forget that it exists, please. Use a float, use an int, anything else. Store things in tens of cents, and you'll be fine with an int. Really. There is decimal and numeric, and these are super flexible, where you can determine like how many digits before the dot and how many after, or the period, how you call it here in the US, comma. They're super flexible, but they're so big. I had when I studied at university, I had lessons from Andrew Tannenbaum, the inventor of the creator of Minix. He was in a big fight at that moment with Linus Torvalds about the intellectual property rights of Linux, because Linus might have borrowed something from Minix. He called these things are hairy. Yeah, just, don't touch them if you don't have. and there are two more. There is JSON. And I don't mean JSON-B. JSON-B is actually pretty cool. It's in a way similar to how timescale stores its things in a kind of compressed way. In JSON-B, you can add indexes within the values of the JSON. And that's pretty cool. But the classical JSON is just text storage of your stuff. And why would you do that? I mean, if it's so messy that you have to store it in a JSON string, then just make sure that it's not so messy. Then you can actually put it in some data types. No, that works like especially for flat JSON. Don't use it. It's there because of compatibility reasons, but none whatsoever otherwise. And the worst one is byte A. That's just binary stuff. I've seen, probably you've seen it as well, people storing images in their databases. Why? But no. Working with binary values in a database is just not something the database is actually built for. If you have to, okay, but please don't. Yeah. Oh, I could go on for days.
No, that's a lot of wealth of information that you have there, and that's great. I'll make sure that I'll put it on the link of our podcast there to your website and the PDF there, because it's a lot of wealth of information there.
Oh yeah, there's so much to talk about. And there are so many people that have so much experience with this. And usually this experience comes with anecdotes of how things went wrong, obviously. I mean, you learn from failures, and
How we learn.
that's true.
Yeah, that's how we learn. Exactly. We fail, but we become better. We learn from it. Or at least
I
have the
hope so.
theory
I
behind
really hope so.
it. Have the theory behind it, at least.
Yes, exactly.
Well, Ellert, it's been really, really good talking with you. I think we covered, wow, it was more than an hour already and counting, and we're still going, but it was a wealth of information.
So when
It
is
was
the
great
next
talking
session?
with you. Yeah, let's start scheduling it, preparing it, because I'm sure we have something. It's glad to see you're providing and giving back to the community with your course as well, too. That's not often heard. In fact, including myself, I try to do it by podcast and by YouTube, but still, it's nice to see to have that hands-on and seeing the instructor there.
Yeah. I'm not so sure how much I give back to the community, because I earn my living with it, so it's also free. Although I'm planning to do at least a part of the course, just maybe put it on YouTube or on Udemy or something. But I really prefer to give courses face to face, live, so that people can actually make assignments while they're struggling with it. I can give tips and make jokes, and that works.
It's a nice experience.
It works really well to do a really interactive course. And I'm usually not such a traditionalist, but for this, face to face works best. Yeah,
that's a great idea. Well, Ellert, we're going to start preparing for the next one. And you have any parting thoughts or notes for the viewers here?
I have an anecdote. I have a short anecdote, and that is about a very, very hot topic. It's about AI. Customer came to me and he said, "Yeah, I had this query. It was really slow. So I had ChatGPT rewrite it for me. And it does almost exactly what I wanted. Can you have a look at it?" I was like, okay, wait. It does almost exactly what you want. What does that mean? Yeah, it's missing some records. I expect this, but it gives me like 5 out of 7. You're really lucky, because usually what ChatGPT generates is either complete garbage, just like fantasy, or it works. At least it seems to work. But you were really lucky because it didn't work right from the get-go. And that means that you got the problem. So what you have generated is garbage, because you don't understand what it generated and it doesn't do what you want. Let's just throw it away and start anew. But you were the lucky one, because there are also people that use this. They generate some SQL statement and it works. And it works. And then suddenly it doesn't work and nobody understands why. Because it was generated by an AI, and how does it work? Nobody knows. And then you get in some corner case situation and suddenly things don't give results or give the wrong results or whatever. So yeah, it's really great for image generation and story writing, not for code.
Yeah, it's still not there. Our jobs are safe for a while at least.
So the explanation out of the underlying explanation of that is actually really simple. All these GPT things, they are generated text creators. They create text by saying, okay, if this, then probably this, then probably that, this and this follows that and that. Such a process does not understand what you want. You can give prompts and you can make it try to, like, okay, I try to explain it, but you're actually not explaining anything, because it doesn't have an actual understanding of either what it's doing nor what you want. The only person that understands these both things is a person that can code this. Either you as a person that is giving this prompt to this GPT thing yourself, or maybe an experienced DBA or maybe a programmer. Only then, through interaction, through understanding, through talking, explaining, giving examples. I want this. It has to generate that from this source. It has to come that. That is understanding. There is no AI that understands anything at the moment.
Our jobs are safe for at least for a good while until they start trying to roboticize them or something. We'll see how that goes.
We'll see. So the database world is quite conservative. I mean, I have seen more conservative areas. I have worked with chemists, for example. Woo, they're so conservative. they prefer to do things on paper, but like lawyers. Yeah, no, but the database world moves. It moves slowly, but it is in motion. Definitely.
Great. That's a great suggestion, idea, anecdote, and even thought. Well, definitely. Thanks for that parting anecdote then. And we'll see you on the next podcast then. You take care until then.
Excellent. Thank you, Doug.
Thank you. Bye.
Bye.